So today I just want to go over some of the problems from the Newton's second law assessment practice that you guys were supposed to complete earlier this week. I just want to go over it so we can make sure that we are all on the same page when solving problems. So there's three equations that we need to know to solve any problems using forces. So I'm just going to write those down at the top. So the first equation we need to make sure we know is that force of weight equals mass times gravity, which was in our notes. We also need to know that F, so the sum of our forces, or net force, is equal to MA. So you might see it written like this, or it can be written like so. And also we need to know that our frictional force is equal to mu times the normal force. So these are three equations that we need to know when working out problems on this practice. So the first thing we need to do is, if we read number 1, we see that we are looking for the normal force, net force, mass, and acceleration. The first thing that I want you guys to get in the practice of asking yourself is, what forces are balanced and what forces are unbalanced? We can see from looking at number 1 that it's only moving in the horizontal direction, which means it's either moving to the left or right. It's not moving up or down, so we know that our our vertical forces are going to be balanced. So we can say that if we have 73 newtons on the bottom, we know we're also going to have 73 on the top. So that's going to be that equal and opposite forces. We can see that it's not floating in the air and it's not falling through the floor, so those two have to be balanced. Next, we need to determine how can we find our mass, acceleration, and net force. I'm going to start by finding the net force, which is pretty easy. So the net force just wants us to know how much of a difference we have between our two unbalanced forces. So if we go back to our free body diagram, we can see that we have 50 newtons here, 10 newtons here, so we can say these two forces are unbalanced because they're different magnitudes. So all we have to do is to find our net force. We're going to say F net equals 50 minus 10, and so we're going to end up with 40 newtons. So your F net is just the sum or the difference between your two unbalanced forces here. Now we're going to look at our mass. So we need to think, how can we solve for our mass since it wasn't given to us? Let's go back to our three equations. First of all, we know we can't use our frictional equation because it doesn't have mass in it. So we know we can either use F equals ma or force of weight equals m times g. We know we can't use ma because we don't know acceleration either. So we can say that our force of weight is equal to mass times gravity. But what does force of weight mean? So force of weight and force of gravity are the same thing. That just accounts for gravity because that's everything, the force that's pulling everything down towards the center of Earth. So we could say that our force of weight is equal to mass times gravity. So we know that our force of weight, I'm just going to plug in our numbers, is 73. We're looking for mass, and we know gravity is 9.8, or we're going to round it up to 10 just to make calculations a little easier. And so then all we have to do is to solve for m. We're going to divide both sides by 10. So we're going to end up with a mass of 7.3 kilograms. Because remember, we measure mass in kilograms. All right, and then the last step, acceleration, we're going to use our second equation up top. We're going to say F equals ma, or F net equals ma. We know our F net is 40. We know our mass is 7.3. So we're going to end up getting a by itself by dividing by m on both sides. So we're going to end up with our 40 divided by 7.3 to give us our acceleration. And so we should get something around 5.5. So we're going to say 5.5 meters per second squared. All right, so that's how you solve for our mass, acceleration, net force, and normal force. But now I want to solve for one that uses mu, or that weird symbol that just tells us our coefficient of friction. So we're actually going to jump down to number 3. It says it gives us an 88 kilogram object is sliding to the right and encountering a friction force that slows it down. The coefficient of friction between the object and the surface is 0.15. Determine the force of gravity, normal force, force of friction, net force, and the acceleration. So the good thing here is everything's blank, but the problem gives us some of the things that we need to know. So it says 88 kilograms, so we can go ahead and plug that into our mass blank, because we know we measure mass in kilograms. And it also gives us this 0.15 number. And you might be thinking, what does that stand for? It tells us that it's the coefficient of friction, and it's also unitless. So it's going to be this Greek letter, or this mu, which is just going to tell us like how hard it is to slide things on that surface. So the larger the number, the harder it is to slide. The smaller the number, the easier it is to slide. All right, so now we have 2 things, and we still have to find the rest. So I'm just going to start by finding my force of gravity or force of weight. Going back to those 3 equations we know, we can say force of weight equals m times g. So we're going to doing our mass times gravity, so I'm just going to use 10. And so we're going to end up with 880 newtons. And since we know it's not moving up or down, we know our force of weight, normal force are balanced. So we're just going to plug in 880 newtons there as well. All right, so then we need to think, how can we find our A? How can we find our net force? So we really can't solve for A unless we know our mass and our net force. But we also can't figure out our net force without knowing what our unbalanced force is. So we're going to have to solve for our force of friction. So we're going to go back to our 3 equations here at the top, and we know that the force of friction is equal to the mu, or that weird letter, times the normal force. So we're going to come down here and say the force of friction is equal to mu times the normal force. And so then all we have to do is plug in our values. The problem gave us our mu, which is also referred to as the coefficient of friction. And we're just going to multiply that by our normal force value. So we're going to get 0.15 times our 880. And that should give us something like 132 newtons. However, it's going to be negative just because it's a force that's slowing us down. So now we can figure out our net force. So we can say our vertical forces are balanced, but our horizontal forces aren't balanced. And so this would really end up being like 132, and there's nothing on the other side. So our net force is just going to be negative 132 newtons as well. All right, then the last thing to solve for acceleration, we're going to say that F net is equal to mass times acceleration. So to get acceleration by itself, we're going to divide both sides by mass. And so we're going to end up taking that negative 132 and dividing it by our mass of 88 kilograms. And we should end up with that negative 1.5 meters per second squared. And we know that negative makes sense because we are slowing down. So it's actually going to be a negative force. All right, so I want to flip over on the back, and I want to just talk about number 4. So number 4, it's all about the F net. So if F net's 0, that means everything's balanced. So that means if we have 37 on this side, we're also going to have 37 here. If we have 150 going down, we're also going to have 150 going up. However, if it says we have 900 newtons going up, we know that our force going upward has to be at least 900 newtons greater. So all we need to do is take that 180 and add 900 to it. And so we're going to end up with 1,080 newtons. And you should be able to figure out the rest from there. But I did want to get to number 5, because 5 and 6 kind of work the same way, but these mention having a constant velocity. And so if you think back to Unit 1, when we hear that word constant velocity, we should automatically think no acceleration. Because remember, the acceleration is the change in velocity, and if so velocity is not changing, we're not going to have an acceleration. So we could go ahead and fill in our acceleration as 0. Another side note is that no acceleration means that all of our forces are balanced. So our forces are only unbalanced if there's a type of acceleration happening. So what that means is that we could already say we know our F net is the sum of our unbalanced forces, but if they're all balanced, our F net's also going to be 0 as well. We can say that we know since friction here is 15, since everything's balanced, applied force is going to be 15 as well. One key thing I want to point out here is that even though everything's balanced, we treat what's happening left to right separate from what's happening up and down. So even though that these two are 15, that doesn't necessarily mean that our forces going up and down are going to be 15 as well. So we're going to solve for our force of weight. So we say that force of weight equals mass times gravity. Thankfully, the problem gave us that mass of 67 kilograms. So all we have to do is take that number, multiply it by 10. We're going to end up with 670 newtons. And since up and down are balanced, we're going to get 670 newtons up as well. So I just wanted to work a couple of these as examples to point out that that word constant velocity lets us know that we have no acceleration, and so all of our forces are going to be balanced. However, if we have a type of acceleration, we're going to have unbalanced forces. And so that unbalanced force is what causes a change in motion. If you think back to Newton's first law, you know that an object stays in motion unless acted upon by a force. So if there's not a force changing the motion of an object, then our net force and acceleration is just going to be 0. So I hope this helped, and if you guys have any questions, please email me.